Okay, we're going to talk about section 2 is multi-stage experiments and modeling games.
Yes, that's the one I'm on. I
All
believe it's 5 questions. Yes, okay.
All right, so in this, our objectives in this section are one, we're going to look at multi-stage experiments. Next thing, after we do that, we're going to do independent events. 3, we're going to look at conditional probabilities. And 4, we're going to look at modeling games. So far, so good. So those are the 4 topics we're going to talk about. All right, so first one, let's look at multi-stage experiments. What is a multi-stage experiment? An experiment is when you're trying something out. It's a pretty much a guess and check. This one is an experiment with multiple paths for a solution. So let's look at flipping a coin. Flipping a coin. A coin has only 2 sides. It has heads or tails. Okay, from section 1, remember, when you hit the list of all possible outcomes is called the sample space. When we talk about the sample space, those are all the possible outcomes. It has to be in a list form. So if we have our initial thing here, this is where we're going to start. When we flip the coin, what can happen? We could either have a head or we can have a tail.
Yes.
If we flip it again, what can happen? If the first one's a head, the next one can be a head or the next one can be a tail.
Mm-hmm.
If the first one was a tail, and we flip it again, it could be a head or a tail. And you see, so every step we go further, the next one after that, it could be head or tail, head or tail, head or tail. So if we look at the possible outcomes, these are with 3 flips of a coin. So our sample space now of possible outcomes, we can have head, head, head. We can have head, head, tail. We can have head, tail, head. We have head, tail, tail. You see what I'm doing here?
Yes, sir.
So now the first one, that was with head. Now the first one was a tail. We have tail, head, head. Tail, head, tail. We're looking at all possible outcomes. Tail, tail, head. Tail, tail, tail. One, two, three, four, five, six, seven, 8. We have 8 possible outcomes. So that's what a multi-stage experiment's all about. All right, so now, what if we have a bowl with 5 red marbles, 3 green marbles, and 2 yellow? So in our first event, there, for us to get a red, what is the probability of us getting a red marble? Remember, probability, the term probability of an event is part over total. So the number of reds over the total number of marbles. So there are 5, 6, 8, there are 10 marbles in total, but there are only 5 red marbles. So in the first draw, for us to get a red marble, we have a 50-50 chance. For us to get a green marble, there are 3 greens out of 10. And to get a yellow marble, we have 2 out of 10, which is one. We can simplify it as 1/5. Okay, this is important to understand what this concept's all about, because we know we have 10 marbles total. 5 plus 3 plus 2 is 10. That's the total. That's the bottom number. We have 5 reds, so 5 over 10, 3 over 10. We grab a marble. These are the probabilities. Now, in the next step, what's the probability of getting a red, green, or yellow? Now, whenever you talk about multistage, you have to discuss its with or without replacement. What do you think this means, with or without replacement? Why does that make a difference?
Let's see. Are you replacing the numbers?
No, remember, we're dealing with marbles here.
Okay,
So with replacement, if you have with replacement, that means you'll always have the same number of marbles.
okay, so that won't change.
Yeah. So in other words, all these probabilities will not, if I have with replacement, all these probabilities is 1/2, 3 over 10, 1/5 will always be the same.
Okay.
This will be 1/2, 3 over 10, 1 over 5 on all of these.
Mm-hmm.
Suppose I grab a marble, see the color, and put it back. Things change without replacement. Let's just look for the red ones, for example. In the first draw, to get a red, I have 5 reds out of 10, which is 1/2. Okay, I get a red, and I keep it, and I keep it. What's the probability of getting a red on the next one?
The same.
No, remember, I kept it.
Oh, you kept it.
So I found a red one, so I kept it. So now there's not 5 left, there's only 4 left.
It'll be 4/10.
Nope, remember I took one, so it's 4/9.
9. Oh, okay.
Yeah, without replacement, it means I keep that marble because now there aren't 10 more marbles in there. There's only 9 because I kept one.
Okay.
And yeah, so it changes the odds. For the green, we have 3 greens out of 9, which now makes it 1/3. So every time you keep one, the bottom number changes. And sometimes the top changes if it's the one you're looking for.
Okay, I see.
Yeah, so that's the problem when it comes with replacement because things change a lot.
Okay.
Now, the question is, let's look at this one's with replacement. This one's without. Now, how do we find the probability?
Mm,
When you have multiple stages, what were you going to say?
I'm getting confused because when I seen a lot of numbers, that's where I mess up at.
Yeah. Okay. Let me start with just one bowl. I have one bowl, and in there, I have 5 red marbles.
Okay.
So if I pick the first one, it's going to be red. What's the chance of me picking a red marble?
Okay, you have 5 red marbles in total, right?
Right. So because remember, if I'm looking for the probability of red marbles, how many red marbles are there?
5.
How many marbles are there total?
5.
5 divided by 5 is 1, so it's 100%.
Okay.
Because this is the number of red marbles. The bottom number is the total number of marbles in the bowl.
Okay.
Okay, so let's change it a little bit. I have 5 reds and 2 greens.
Okay.
Now, what's the chance of me getting a red marble?
It's 3 out of 5.
How many reds are there? Because
3.
reds are the circles, greens are the crosses. So they're 1, 2, 3, 4, 5.
5. I'm sorry. I was counting.
5 over what?
5/7.
Very good. So that's the probability of picking a red. What's the probability of picking a green?
2 out of 7.
Very good. Okay, now let's pretend this is without replacement. So we got the first one, it was red. Now, when we draw the second one, the second time, what's the chance of getting a red now?
4 out of 6.
Very good. 4 out of 6. Number of green ones?
1 out of 6.
No, remember, okay, yeah. So it's 1 out of 6 because we took a green one. All right. Let's do, now the first one we drew was green. So now what's the probability of the next one being a red?
Is it 3 out of 5?
Now remember, we took a green one. So a green one's gone.
Okay.
So we still have how many reds?
We still have 5 reds.
Out of how many now? Because we lost one from this first time.
6.
Yeah, so it's 5 over 6. Okay, now the second draw, we got a green in the first one and we green in the second. So what's the probability of that one?
So we took 2 greens.
Yeah, the first one, the probability was 2 out of 7. So we took 1 green. So now what's the probability of getting green on the second?
So it's 1 out of 6.
Very good. Very good. So yeah, so this is how you calculate each step along the way. You have to see, okay, I got a red, so I got to take away a red. So now I only have 4 out of 6.
Okay.
All right, now to find the probability of getting a red and a red, but remember, the important word here is the probability of a red and the probability of another red.
Okay.
The reason I made and so important, because whenever you see the word and, it means multiply.
Okay.
So we have 5 out of 7. That's the first draw.
Mhm.
And then 4 out of 6 is the second draw.
Okay.
And in multiplying fractions, always, can we cancel anything top and bottom?
Cancel the top.
Well, no, we can't. We could cancel this one. We have 2 goes into 4 twice, 2 goes into 6 3 times.
Reduce.
Reduce, right? So can anything on top cancel with anything on the bottom?
No.
No. So if that's the case, now we can multiply top by top, bottom by bottom. Those are your chances of picking 2 red marbles.
Okay. So after all, okay, even if I'm using letters, it's always gonna be the same. Do I always have to multiply?
Yes, because when we do a multi-level experiment,
Mhm.
this is it. In order to get 2 reds, the first one has to be a red and the second has to be a red. So that's why I use the word and.
And
The first one's a red and the second is a green. Then we do that probability.
okay.
All right. So, and okay, so since the word and means multiply, the word or means addition.
Okay.
So in other words, if I said, what's the probability of getting a red on the first draw?
Mhm.
What's probably getting a red on the second draw? Let's look at that one.
So do we just do the 2 fractions, right? Or am I looking at the 10 over 21?
No. It's going to be 2 different fractions, right?
So I add, which is 7.
Because remember, what this means is one possibility is we can have a red and red or red.
Mm-hmm.
We can have green or red. So what's the probability of this is going to be an or, so you're adding the fractions.
So I'm adding 5 over 7 and hold on, I can't see the top.
Oop, I'm sorry.
5 over 7 and what's the top number?
So we're looking
12.
at Yeah, 5/7, 2/7, 2/3. There's two. This is 1/3. I'm sorry. Yes, yeah. So there. So now what we're looking at here for this question, what this says, I want a red on the second draw, right?
Mm-hmm.
So what can happen? That means I can have a red on the first one and a red on the second, or a green on the first one and a red on the second. See what I'm saying? Because since this is the second draw,
Mm-hmm.
we have to look at all the possibilities of the other colors being the first draw.
Oh, okay, I see.
Yeah, because if the first one's a red, we want red on the second. So what's the probability of that? The probability of a red, or the probability of a green, red. As long as red is the second draw, that's what I'm looking at.
Okay.
So what's the probability of a red?
Are we still doing with the marbles?
Yes, we're always using the same ones here.
Okay, so it's 5 out of 6. I mean 7.
Yeah, yes, it's 5/7. That's for the first one, R, and R in the second is 2/3,
Yes.
which we did that here.
Mm-hmm.
So this one is 10/21.
Plus
Now let's look at green, red. 2/7.
and 5/6.
Yeah, 2/7 times 5/6. Nothing. Oh, 2 cancels. 2 goes into 6 3 times. So it's 5/21.
Okay.
So this is green, red. So the probability of green and red is 5/21. And we just add the top. 15/21, right?
Okay. Okay, I see.
And what that means is if we had a bowl of 21 marbles, if we drew it 15 times, we'd get a red or green red in that order.
Okay.
All right, so that's with and without replacements.
Okay.
All right, let's see what else. What's the next one we're supposed to do? Independent events. Let's get that's the second one we're gonna talk about. They see a squirrel. All right. And what do you think independent event is?
All right, Professor, I couldn't hear you.
No, dogs, quiet, stop barking. An independent, what do you think independent event would be?
In,
Yeah, basically an independent event is the event probabilities do not affect each other. So if you have two events, event 1 and event 2. The probabilities do not have anything to do with each other. So let's look at this. Event 1 is a flip of a coin. Event 2 is a roll of a die. Okay, I flip a coin. It's either going to be head or tails. Is that going to change the probability of the second one?
No.
No, this one's probability of the second one is always going to be 1/6 because a die has 6 sides. So that's what's called independent events.
Okay.
When one event doesn't affect that of a second event.
Okay.
Flip a coin 3 times. Let's make it, it'll be too long. Let's do 2 times. So here is our beginning. When you flip the first coin, what are the possibilities? We have head or tail. What's the probability of getting a head?
1 out of 2.
Very good. And tail?
1 out of 2.
Okay, so the first flip is a head. Now we flip it again. What's the probability of getting a head?
1 out of 1.
No, you can't
1 out of 2.
change. Yeah, because you can't change. A coin's always going to have a head and tail.
Yeah.
It's always going to be 1/2.
1 out. Mm-hmm.
Now, so what's the probability of getting a head?
Is it the same? Or would it be 2 out of 2?
No, but remember, the first one's a head, and the second one is a head. It's an and statement.
Oh.
So
we multiply.
We multiply them. So we have 1/2 for the first event times 1/2 for the second event. Nothing cancels. 1 times 1 is 1. 2 times 2 is 4. How about the next one? The probability of a head and a tail.
Is it 1 out of 4?
Yeah, because probably getting a heads is 1/2. The probability of getting a tails is 1/2, so it's 1/4 again.
Are you writing it down?
Me?
Mm-hmm.
Yeah.
Okay, it's not loading. I was like, I couldn't see it. It was still stuck on 1/2. That's why I was confused.
I'm sorry.
Okay, now I see it. I'm sorry.
Yeah, so the probability of tails and heads is
Okay.
1/2 times 1/2, which is 1/4 again. And the probability of 2 tails is 1/2 times 1/2. Now, we know this is a valid probability because here's a rule. If you add all the probabilities that are possible, then your answer should be 1. You see, can't look where I get that from.
From 1.
Yeah, why
The
is
top numbers.
if you add up all these together, so all my possibilities, I have 1/4 plus 1/4 plus 1/4 plus 1/4. That's all 4 of these.
Mm-hmm.
I have a common denominator of 4.
Mm-hmm.
1 plus 1 plus 1 plus 1 is
Mhm.
4/4, which is 1,
1. Yes.
which is equal to 100%. Right. So that's how I can tell if a experiment or a set of probabilities is correct or not.
Okay.
Ooh, okay. Let's look at how much things change when we have, let's get one die. A die is a cube that has the numbers 1, 2, 3, 5, 6. There are 6 sides. So the probability of getting a 1 if you roll a die is what?
1/6.
Very good. The probability of getting a 2?
2/6.
No, 1/6.
1/6.
Probability of getting a 3?
1/6.
And so on and so forth. So you have
Mhm.
probability of getting a 4 is 1/6, 1/6, and 1/6. If we add them together, equals 1.
Yes.
Now, here's where a problem occurs. What if we had 2 dice? They each have 1 through 6. What's the probability of getting a 1 if you're rolling 2 dice?
1 out of 12.
Nope.
1 out of 6. Not possible.
Because remember, on a die, the smallest number that they have is a 1, right?
Mm-hmm.
If I roll both of them and they both have 1s, can I get a 1?
No.
No. The smallest I can get is a 2. It's 1 out of 36.
Okay, because you multiply.
Yes, because there's 6 sides here, 6 sides here. 6 times 6 is
It's
36.
Okay.
Now let's build a table of what it looks like. So the smallest you can get is a 2. That's by rolling a 1 and a 1. The next one is a 3. 1 and a 2, or a 2 and a 1. Remember, these are both independent events
Mm-hmm.
because I roll this one, and then I roll this one. They have different numbers. So the first one could be a 1, the second one 2, or like the first one. So I have 2 possibilities here. Possibility of getting a 4.
2 out of 1 out of 2.
1 out of 1 and 3.
1 and 3. And a 2 out of 2.
And then a 3 and 1.
Yeah.
How about a 5?
A 1 out of 4. A 2 out of 3. And a 3 out of 2.
And then
A
a
4
4
out of
and a 1.
1.
Because remember, these are both independent events. They have to equal 5.
Okay, 1 out of 5. 2 out of 3. A 4, I'm sorry.
Because if you notice, the patterns change. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3, 4. So this one starts at 1. It's going to end at 5. So it's 3 and 3.
3 and a 4 out of 2.
And then 5 and a 1.
Out of 1.
How about a 7?
1 out of 6. A 2 out of 5. A 3 out of 4. A 4 out of 3. And a 6 out of 1. Oh, 5 or 2.
Yeah, you have to keep the numbers going.
6. Oh, yeah.
Next one.
1 out of 7.
I knew it. I knew it. Everybody falls for that. How many sides are there on a die?
You said 6?
Yep. So you can't have 1 and a 7.
Oh,
So it has to
1 and a
be
6. Or 2 out
2
of
and a 6.
6.
Yeah.
Oh, okay.
If it's 1 and 6, that equals 7. So 2 and 6 is 8.
8, yeah. So 3, 5, 4 and a 4. A 5 and a 3. 6 and 3.
6 and a 2. Okay, so let's look at the next one.
Is it a 3?
And a 6.
A 4 and a 5. 5 and a 4. Oh wait, that's
Very
4.
good. Yeah,
A
5
5
and a 4.
and 3. And then a 6 and a 4, or 6 and a 3.
6 and a 3. How about a 10?
A 4 and a 6.
Very good.
A 5 and a 5.
Very good.
Is a 6 and a 4.
Right. Because the bottom and top ones are always flips of each other.
Okay. Okay, so it's a 5. Is it a 5?
Mm-hmm.
5 and 6. And a 6 and a 5. I see it's getting smaller.
Right. It
Like
goes.
a pyramid.
That's exactly right. That's exactly right. Where the smallest is a 2 and the largest is 6. So let's look at the probabilities here. We know we have 36. If we count all of these, there's 36 of them.
Okay.
So the probability of getting a 2 is 1 out of 36. 2 out of 36. 3 out of 36. 4 out of 36. There's 5 of those. There's 6 of those. There's 5 of those. There's 4 out of 36. So those are the probabilities.
Okay. I see.
So that's a this one here happens the most. This one here happens 1 out of every 6 times you get a 7, which is like come in Vegas. If you roll a 7, you lose. So yeah, do you have to think about, since we're dealing with 2 dice being tossed, what is the outcome? What are the outcomes? If we had 3 dice, it would go even further. We'd have 218 numbers if we added another die. See how fast they grow pretty quick, pretty fast. I mean, it makes it much more difficult that way. All right, so what's the probability of, with this chart here? You have 2 dice. What's the probability of rolling an even number or a 7 and 11?
Is it the same number?
No. Remember, if you have 2 dice, we're doing 2 dice, and you roll them, what's the probability of getting an even number? Look at the thing you built down here. An even number is a 2, a 4, a 6, 8, 10, or 12. So what's the probability?
6.
Nope. First one, the
1.
probability of getting a 2. So here's what it looks like. The probability of getting an even number. So that's the probability of getting a 2 or a 4 or a 6 or an 8 or a 10 or a 12. That's what it means, because we have to break it down to the statement that has either and or. So if I just said it's an even number, I didn't say which one, it could be any one of those. So we have to look at all these possibilities. The probability of 2, or is a plus. The probability of a 4, plus. The probability of a 6, probability of an 8, probability of 10. So that's how you have to separate the equations. The question says probability of an even number. An even number is 2, 4, 6, 8, 10, or 12. So they're all ors. And then we have to break it down. So what's the probability of getting a 2?
1 over 6 over 36.
All right. The probability of getting a 4?
3 over 36.
Probability of 6?
A 5 over 36.
8?
A 5 over 36.
10?
A 3 out of 36.
And a 12.
A 1 out of 36.
All right. So since you have a common denominator, 36, you just add the tops. 1 plus 3 plus 5 plus 5 plus 3. So we see that these are both numbers are both the same on both sides. 5 plus 3 plus 1 is 9. 9 plus 9, so it's 18 over 36, which is 1/2.
I see.
So that's the probability of getting an even number. The probability of a 7 or 11. So that's probability of 7 or probability of an 11. An or is a plus. So the probability of getting a 7 is 6 over 36. Or 11 is
2 over 36.
2 over 36. So add those together, we get 8 over 36. So we know 4 goes in both of them. 4 goes into 8 twice. 4 goes into 36 9 times. So the probability of getting a 7 or an 11 is 2 over 9. Which means every 9 times you roll, you'll get
2.
either a 7 2 times, right? Make sense?
Yes, sir.
Yeah, the hardest part about probability is breaking it down to its simplest forms.
Yeah, that's my problem.
That is by heart the hardest part. Okay, let me see. Some more examples here. So yeah, those are the same things. Here's something else. It's called a complement. And I don't mean good job. What a complement means is, I'll show you what it is. Remember, if you add up all the probabilities, you have to equal 1. The sum of all probabilities equals 1. So there are 2 types of probabilities. The probability of getting it answer correct, or the probability of getting an answer incorrect. That equals, that's what that means. It's whatever's not in that list. Now, so basically what this is, what this is important is we can figure out the answer. We subtract from both sides. This is what's called a complement. If you take what you want plus what you don't want, that equals all the possibilities. So what you don't want, take away from 1, what you're left with is the answer. In other words, let me give you an example. What's the probability of rolling 2 dice and getting a number bigger than 4? Remember, we have all these up here.
It said a number bigger than 4.
Yes, if you roll 2 dice, what's the possibility of getting a number bigger than 4?
Is it a 5 out of 36?
Any one of these, they're all bigger than 4, aren't they?
Mm-hmm.
So that's a lot of numbers to add. So what's the only thing we don't want? We don't want a 2, 3, or 4, right?
Yes.
Those are pretty easy. Let's add those. Probability of 2, probability of 3, and probability of 4. So the probability of 2 is 1 over 36. 2 over 36, 3 over 36. So we add up all those, we get 6 over 36.
It's just 2 over 6.
Well,
Or
actually,
2.
it'd be 1 over 6. But let's leave it.
Or
Let's
1
leave
over
it this
6.
way. Let's leave it this way right now,
Okay.
because this is what we don't want. What we want is number bigger than 4. Using this rule here, we know it equals 1 minus what we don't want. What we want is equal to 1 minus what we don't want. So it's 1 minus 6 over 36.
Okay.
Common denominator is 30, so it's 36 over 36 minus 6 over 36 equals 30 over 36. So instead of adding 5, 6, 7, 8, 9, 10, 11, 12, we could find out what we don't want. It's a much smaller set. Subtract that from 1. What we're left with is the answer. This is the sum of all the numbers greater than 4.
I see.
So this rule here allows us to, if this is pretty quick and easy, if our answer is pretty quick and easy, like probability of 2 or 3, just put it in there. But if it's a larger set, find what we don't want, subtract it from 1, whatever we're left with is the answer.
Okay.
That's called the complement.
Okay.
All right. Some more symbols that you have to get used to seeing. We have 2 elements. These are the set notations. What this symbol here means is and. This symbol here means or. And means multiply. Or means add. All right, now, what does that mean? Let's look at the same example we just had. I'm going to say A is equal to the numbers 3, 9, and 12. B is equal to 5, 7, 9, 11, 12. Remember, all these are numbers that correspond to these outcomes. So now what this means, it's an and statement. What it means is it's an intersection. Same numbers in both sets. So that this one says, what is the intersection between A and B? So in other words, what numbers do they have the same? That's what this one's talking about. So in here, what would they be? What numbers are same in group A and B?
9 and 12.
Right. So the probability would be 9 and 12. So the probability of 9 was 4 over 36 times 1 over 36.
So it gives you 5 over 36.
You're multiplying
Oh, 4.
4 over 36 times 36. It's a big number. One, 2, 9, 6.
Okay.
Now, how about the other side?
Is it the same?
Well, no, this one now is an or statement.
Oh,
Or
okay.
means a union.
To add.
Combine both sets. So we have 3, 5, 7, 9, 11, and 12. Probability of 3 plus probability of 5 plus probability of 7 plus probability of 9 and 11 and 12. We'd find all those probabilities and add them all together.
Okay.
Yeah, so probability of the 3 would be 2 over 36. 4 over 36. Let's see. 7 is 6 over 36. 9 is 4 over 36. 2 over 36, 1 over 36. Six and 4 is 10, 14, 16, 18, 19 over 36. So those are the differences. The union means put both groups together. Notice I don't have any overlapping. Even those 3 and 9 and 12 are overlapping. I only put it down once. Actually, that pretty much finishes the no, conditional. Any questions so far?
No, Professor.
Okay. What is, when you hear the word conditional, what does that mean?
Conditional fractions.
Here's, I'll give you the formal definition first, and then we'll talk about what it means.
Okay.
Because if you think about it, conditional, parents give the kids all the time, if you don't clean your room, then you can't go anywhere.
Mm-hmm.
That's conditional. It means it's an if-then statement.
Okay.
All right, here's the formal definition for conditional probability. If we have two sets, A and B, are sets in S. Remember, S is the sample space. And the probability of A does not equal 0. This would be important for in a second. Then a conditional probability that an event B occurs So if A and B are sets in a sample space S and A is not 0, then a conditional probability that an event B occurs given that A has occurred or occurs first. Then it's given by this. So if A and B are sets in a sample space S, and P of A is not equal to 0, the probability of A is not equal to 0, then the conditional probability that an event B occurs, given that the event A has occurred first, then it's given by this probability.
Okay. I have like 10 more minutes before I go to work, but I'm still gonna be on here until then.
About how many minutes? 5 minutes?
10.
10 minutes? Okay, yes, this should be enough for us to do this one. So, yeah, we know what this symbol means here. That's where they overlap. And this is probability of A occurred. Now you see why it's important, why it said the probability of A has occurred. It can't be 0.
Okay.
So here's an example of how we can work that one out. What's the probability of rolling a 6 if we know that the roll is an even number? What's the probability of rolling a 6 if we know that the roll is an even number? Okay, remember, we have to relate it back to this, because you see this is a conditional. The probability of this, whenever you see the word if, that means conditional.
Okay.
Remember, I said up earlier, it's an if-then statement.
I'm
So
not
what's the
for sure why it's going slow. Can't see nothing you're writing.
Can you see anything now?
Okay, I see it now.
I'm sorry, I don't know what. Oh, probably the storm's coming around. Okay, so the probability of rolling a 6, if we know. So there's the if statement. That makes it conditional. So what we have to do is relate this statement to this formula. How will we do that? So we have to figure out what is A and what is B. So this happens second. So that's rolling a 6. And A is has to be an even number. It's very important because A has to happen first before B. And A is the roll of an even number. Then B is rolling a 6. All right, so looking at the formula here, probability of A and B over probability of A. So what's the probability of the top one? Even number and a 6.
So 2.
No, it's one die.
Oh,
We're looking for isn't 6 an even number?
yes.
Yeah. So how many times can 6 be rolled?
One time.
1 out of 6, right? Because there's 6 sides.
Mm-hmm.
And A is an even number. How many even numbers are there on dice? On one die?
3.
3. So it's 3 over 6. So this is the probability of we have an even number and it's 6, which is 1 over 6, and over the probability of an even number, which is 3 over 6.
Okay.
Since it's a fraction over a fraction, take the top fraction, leave it alone, and flip the bottom fraction. So the 6's cancel. We get 1 over 3. And that's the probability of rolling a 6 if we know that the number is going to be an even number.
Okay.
Oh yeah, that's mostly it, because modeling is that's we've been doing modeling all along. So
Okay.
that's it for that section.
Okay.
Yeah, it builds this chapter is difficult because it builds on stuff. The concepts are pretty easy. The
Mm-hmm.
probability of something happens is how many times do I'm looking for it out of all the possible answers. But
Okay.
when we get to conditional probabilities, it gets a little bit more hairy. All right, so try your best on the homework. If you get stuck, shoot me a remind.
Okay, yes, sir. And are you going to be having Zooms often or?
Um, I'm looking at the way I see it is if we can have Zoom meetings every day for this week and next week,
Mm-hmm.
we could pretty much finish most of the course,
Okay.
and then start again after Christmas to finish up the course. And then that way, I mean, we have until the 14th. We have a lot of
Mm-hmm.
time to cover this stuff. But I mean, some people already finished the first 3 chapters.
Oh, really?
Yeah. So, but I'm not going to move so fast it's going to hurt anybody. We're going to move at a fair pace to try to finish up. So I don't mind. I don't mind having class 4 days a week or 5 days a week.
Okay.
So yeah, we'll look at that. And each class I have, and that's what I ask everybody. I want to ask everybody, how often do you want it? What time is 2 days a week, 3 days a week enough, or you want it 5 days a week? So that's what I have to ask everybody what they want.
Okay.
What's your vote?
I would say about 2 days a week.
Okay, that's actually that sounds really good. That because we can lecture on Monday and Wednesday, and give you
Mm-hmm.
Tuesday and Thursday, so that you could do the homework and you can ask me questions.
Yes, that sounds great for me.
That'll work. Yeah. Okay. So that's what I'm gonna shoot out to everybody. Since a lot of people are working, then we'll have it at 7 o'clock at nighttime, Mondays and Wednesdays.
Okay.
Thank you so very much.
Okay. Thank you, Professor, for
You're
helping me.
very welcome. Have a great day.
All right, you too.